take a real world example. Google uses clustering algorithm to cluster or to club or to group similar news articles. News articles are not labeled. That means when you have a news articles, uh, we do not know on what topic this particular article is. We of course have the title of the news article, but that doesn't tell much about the topic in which the article has been written. That means the titles could be different for each articles in different for a particular article in different newspaper. Now what Google does is it scans through the entire web page for each news article and finds out similar articles. Now it can't find out what exactly is the topic involved. So it doesn't know what the topic is, but it knows is that these articles are similar. So here is an example. So we have this cluster of articles and they are of similar types. Okay. So Unilever threatens to pull ads from Facebook and YouTube. Okay. So that's in the newspaper Guardian. In BBC News, it says that Unilever threatens to pull ads from Facebook and Google. Unilever threatens to pull ads from Facebook and Google. So we have articles being published in many different news sites, whether it's Guardian, News, BBC News, Fortune, Quartz, The Times, and so on. So Google scan through these web pages, hundreds of thousands of web pages to find out similar news articles. It of course will never tell us the topic on which the new articles have been written. It just groups them, and that's why it's an unsupervised and it works on unlevel data where we do not know what exactly is the topic, but we know that the topics are similar. Okay? And most real world data will be in unlevel form, whether it's your text messages, whether it's your social media data, whether it is uh, a lot of this data available on Google web pages, on blogs, on the comments on different social media content. Well, these data will be unleveled. So in real world we have more unleveled data than the level data, and getting level data is very expensive. So clustering is very helpful whenever we have unleveled data. So another illustration of clustering. Here you can see three types of different data points. Now it is very clear to human eyes that there are three clusters of data, right? This is one, this is other one, this is the third one. Right? And we know it when we see it, right? But how does clustering algorithm finds out that there are three segments or three clusters of data sets or data points? Well, it tries to find the distance. It tries to find the distance. Let's say you see the distance between these points, like the points in, let's say this is circle 1, this is segment 1, segment 2, and segment 3. The distance between points, the black points, between segment 1 and segment 2 is quite large. But distance between each point within segment 1 is relatively much smaller, right? So what we are interested in is within cluster distance, within cluster distance, and between cluster distance. That means within the cluster, the distance should be as less as possible, whereas between cluster, the distance between the points, different points or element of that cluster, members of that cluster, should be very high. Okay. So similarly, the distance between points between cluster 2 and cluster 3, or whether it's cluster 1 with cluster 3, is quite high, whereas between the points within the cluster is much smaller, right? And that's the basic idea or basic thinking about how the clustering algorithm works. And there are different variations of it, like how do we find within cluster distance and between cluster distance, And based on how we find these distances and based on how we come up with these segments, there are different sets of or different types of clustering algorithms, and we'll see a few of them. One more real world use, many retail companies, they want to group their products into different sizes. Like, an apparel company might want its t-shirts to be clubbed into small, medium and large t-shirt. And given a set of features without having a label, if with the help of the feature, the algorithm is able to find out um, set of clothes which are, very small, which are medium and which are large, is also one, example. In marketing is very useful because marketing data do not have a label. Many times you do not know much about what it talks about, but you have some data about customers with the products and so on. So you can have marketing segments, and then later on with expert judgment you can, analyze this segment and sort of come to some conclusion.